So again, chin up if it didn't go so well. You'll get another go at it. We want to grow, okay? And if you need help, let me know. We'll help you out. That's why we get paid the big bucks. Not really, but we get paid. All right. So what's going to happen now is somewhat scary, but you can handle it, right? You know how we did one inequality on one grid, one on the other? Now we're going to combine them both on the same grid. But we're going to work with one at a time, so it's okay, right? So that's what's going to happen now. We proceed the same way as before. But now we graph multiple IQs on the same one. Okay. On the same plane. Okay. Use, this is very important, use reverse shading okay, very important. Use reverse shading when graphing systems. We're going to automatically revert to reverse shading. And you will see why in a bit. This means that we shade the false region which will leave the solution region unshaded. That's very important. The solution region will stay unshaded. Okay. Let me do this here. Okay. Corner points. Or points of intersection. POI, right? These are the coordinates surrounding the solution region. Some examples, and I will just show you scenarios, right? So let's say you have kind of like a triangle formed like this. So we're graphing, right? Almost make there be a triangle, and then we'll just add arrowheads like this. And let's say you start shading. So I shade along every line, right? You shade here, and notice that I'm shading the false regions, right? And then you shade along this line. That's false. That's out of the question, right? We're basically shading away the areas that do not pertain. And then we shade this way. So let's say you do this, and it just beautifully turns into a triangle. And we label that area solution like that. And so the points right here, the points of intersection that surround it, make nice big dots there. And we're going to go A, B, C. We're going to call this point A, point B, and point C. Right? Those are the points of intersection. Those are the ones, right? Points of intersection. So A would have a coordinate. B, I would like you to state that on the side, and so forth. So I'll do another example here on the side. I'm actually going to do the X and Y axis because this is something that will happen. So let's say you're only graphing two inequalities. So one of them will come this way. And the other one will come this way. So you've graphed your lines. I should have made one of them dashed, but it doesn't matter. So let's say we shade the first inequality, and we determine that this is all false, because remember we're doing reverse shading as soon as we do systems. And then you shade the other one, and it's also over here. And you're now going to realize that, watch this, the only point of intersection between two lines is right here. And so this whole thing here is the solution. Right? All of this actually goes in onto infinity. This one is not bound. This solution region is bound, and right all around. This one is not. It's just bound here and here, but everything else underneath it is part of it. So in this case, right, the POI is just A, like this. The axes do not count. Okay, so some students will find this intersection here between the x-axis and the line, and same here, and so they'll think there's this, this, and this. No, in this case, it's only one point of intersection at the top. Okay, so it's basically the lines you're actually physically graphing. The intersection of those lines will give you the points of intersection. And now we're going to do our first system. We're going to graph it. 15 minutes, I think you can handle it. I'm going to start a new page. If you have over half a page left, you're fine. But I only have about a quarter there, so I'm going to start fresh because I want to have my graph and the inequalities all on the same. Okay, so here we go. It's going to be a little weird because the textbook does it this way. So I actually went and I scanned the graph the following. System. So today you're probably only going to have time to do one. So here it is. It's a bit scary looking, but don't let that scare you. Squiggly brackets like this. X and Y. Those are the variables that are present in this. You do a vertical line like this. And then you'll write down 4x is greater than 6y plus 12. And then it's even scarier, but I'll make it less scary in a bit, okay? It's like watching Jurassic Park the first time. And then after that, you're like, oh yeah, I got this. It's all fake dinosaurs anyways. Right? There we go. So that's the first one. And the second one, and by the way, I'm introducing you to something we call set notation, which will come back in grade 12. So then you're not scared. This is 3y is less than or equal to minus 2x plus 9. X is part of the real numbers. That should not be new. This part right here, right? We're saying that all values for x count and all values for y count, all the real numbers. So decimals, fractions, prime numbers, everything, right? So when you see something like this in the textbook, don't panic. Just focus on this, right? Just focus on this. This is the first inequality. This is the second inequality, right? So that's all I want you to focus on. And so when they're asking you, hey, graph this system, no big deal. We're just going to focus on the inequalities that show up in the middle somewhere. And sometimes they're very simple. Sometimes they're longer. So let's go ahead and do that. So 4x, we'll deal with the 4x first. So watch what I'm going to do. 4x minus 6y is greater than 12. So what have I just done there? I brought the 6y over because I want it to look like this. It's basically in standard form. And the reason being is because finding the intercepts is a lot easier when it's like that. So let's find them. So it's 4x is equal to 12. Again, for now, I'm just thinking of the line. X is equal to 3. And that's 3, 0. Done. The other side, negative 6y is equal to 12. Divide everything by negative 6. Y is equal to negative 2. So that's 0, negative 2. I have everything I need to graph now. But I will continue my journey. I'm going to rewrite this now. So the negative 6y is greater than the 4x comes over negative, right? And the 12 is already there. Don't forget about it. Just keep that sign. Then I have to divide everything by negative 6. So what happens now? Let's take care of the sign first. It goes over to the other side. It flips, right? So that's y. 4 over 6. You know what? I'm purposely not going to reduce that. But negative and negative is positive. Minus 2. I box that in because I like to have a quick look at it when I need to find it. And it's dashed. The true region is where? Y is less than? below, right? So you go like this. Ready for this next part? Where are we going to shade if we do reverse shading? We're going to go above. So when you see the true region and the shaded region being opposite, you know I'm using reverse shading. And you need to tell yourself that, or else it'll be very difficult to do that later on. So back up. Now I'm going to deal with that one. And I'm going to bring the 2x over. So it's 2x positive plus 3y less than or equal to, and I'm leaving the 9 on the other side. Two x is equal to 9. Divide everything by 2. X is equal to 4.5. 3y is equal to 9. Divide everything by 3. Y is equal to 3, so it's 0, 3. 4.5. I can kind of fly through this because I know you know how to do it. So for now, I've found my intercepts. Then it's time to rewrite it again. 3y is less than or equal to. The 2x comes over, subtracting, plus 9. Divide everything by 3. Negative 2 over 3. X plus 9 divided by 3 is 3. And it jives, everything good. Here we go. It's solid. True region is below. Where am I going to shade? Opposite, right? I'm going to shade exactly the opposite of where the true region is. So it's almost as if I worked with two different questions, except we're going to graph it on the same plane. Okay? So my intercepts are pretty small. I can just go ahead and do like a 5 by 5 grid. Let's try to finish this, folks. So I'm doing a 5 by 5 grid here. And I'm just quickly going to go 1, 2, 3, 4, 5. 1, 2, 3, sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You got it. It's a 5 by 5. Let's plot the first one. 3, 0, 0, negative 2. My slope is positive. It makes sense. It's dashed. I'm not going to shade until the very end. Watch how far I'm going way over my grid, and that's fine. Y is less than 4 over 6. Kind of bothers me, but I'm going to leave it because it doesn't matter, the 4 over 6 or 2 over 3. Doesn't matter. Quickly, let's do the other one. 4.5 is right about there. 0, 3 is right about there. And that one is a solid line. You want the point of intersection to show up. Are you still with me, right? You're with me? Yeah? Okay. Because I want to get to the shading part. So you labeled them both, and now you go back to your work. 4 over 6, that one I'm shading above. So 4 over 6 is this one. You grab a ruler if you have one, and you shade above it. At first you can just go light, just in case you make a mistake, right? It's like, okay, there, above. And the other one is also above, see? I've told myself that when I got there. So I just go over to the other line and just shade. So when you watch this again, Jurassic Park again, right, you're not going to be as scared, right, because now you know what I'm talking about. So this is actually my solution region. This is my solution region. Whatever isn't shaded, we've basically gotten rid of the false areas. So you're left with what is true for both, okay? This unshaded part is true for both of the inequalities. One more thing, the POI. This is your POI, okay? Would you be able to find that using a calculator? Remember, we did all of that. You type both of these equations in. I'm going to do that before you go. You can pack if you want, but you at least write down the watch this, 4 over 6x minus 2. And that the other one is negative 2 divided by 3x plus 3. I'm going to graph them both. I might have to redo my window. No, I'm good. Okay. And it kind of looks like what we did, right? So second trace 5, enter, enter, enter. It's 3.75.5 POI. 3.75, 0.5.